Good morning student, welcome to VidyaShree Academy. Myself I will be teaching you physics of unit 11th class. And the name of the chapter is chapter 3, motion in a straight line. In this series we are going to do one theorem where we will see how to deduce equation of a motion of a constant acceleration by using calculus method. So this is the name of the theorem where we will mainly evaluate how to solve equation of a motion. How we will see the proof of the equation of motion. From 9th and 10th class we have learned that there are three equation of motion, that is v is equal to u plus 2as. Okay, and second is s is equal to ut plus half et square. And second is, and the third equation of motion is v square u square 2as. One by one we shall see the proof of this equation of motion in this theorem. So let us prove how this equation, these are the three equations of motion. We shall see how the proof of this equation came out of. Okay, so let us see. Let us see the proof of this theorem. Okay, so before going to learn about let us see what is calculus method. Okay, calculus is actually a part of mathematics where we deal with differentiation and integration. Differentiation and integration. Okay, calculus is a part of mathematics where we deal with differentiation of any function and integration of any function. Okay, so differentiation is, suppose f of x is a x square. Okay, so when we will ask to differentiate this function with respect to x, then you should denote this notation, and this will be solved as a 2x. Okay, but when you will be asked to integrate any function, suppose the same function I will take to integrate, and this will be equals to x. This is what the notation of this is how the integration is being noted. Okay, so when we integrate this function, we will get x to the power 3 upon 3 plus some constant c. Okay, so there are some formulas based upon how to solve any function and all those things. So this is what we call calculus method. Okay, so let's see. We already know that proof. Okay, since we know that acceleration is nothing but dv upon dt. Okay, the change in a velocity of any object upon the change in a time. So acceleration is basically change in a velocity upon time. So when consider this equation as equation number 1. When you transpose this dt to the left hand side, you will get a dt is equals to dv. Okay, now integrating above equation on both sides. Let's integrate this above equation on both sides. When we integrate this equation, we will find that since we are integrating this equation, so this is actually being differentiated with respect to t. So when we integrate it, the lower limit will take your time at 0 second. Okay, and the upper limit will be just t. Okay, similarly on the right hand side, your velocity is being differentiated with respect to v, that is velocity. So the lower limit is v0, that is initial velocity, and upper limit is a v, that is final velocity. Okay, so this implies that taking a as a common, we will get 0t dt is equals to v0 v dv. Solving it furthermore, you will get a is equal to, since there is nothing, so upper limit will take place like this, and on the similar hand, the right hand side will be equals to 1 upon v0 upon v. So this will equals to a t minus 0 and v minus v0. Okay. Now solving it, open this bracket, you will get at is equals to v minus v0. This will come out of as equation v is equal to v0 plus t. Just transpose this v0, which is initial velocity, to left hand side. You will get this. This is nothing but the first equation of motion. Okay, so we have proved the first equation of motion. Now we are going to prove the second equation of motion. Now further to solve the second equation of motion, we will further. Now we know that velocity is nothing but the change in a displacement upon change in a time. Okay, so displacement is changing with respect to time. Now what we did in a previous section, we are going to repeat the same process. So just transfer this dt on the left hand side, this will be dx. Now integrating both sides, but we find that since this is changing with respect to time, so it will so now. Okay. Before integrating the things from last equation, that is equation number 1, we have seen that v is equals to v0 plus at. Okay, this was our first equation. Put equation number 1 in the place of v, no? v0. So we will get v plus at dt plus dx. Now integrating both sides. Both sides. So this has been differentiated with respect to time. So while we are integrating, we will integrate when the lower limit will be when time is equals to 0. When time is initially the time is 0 and the final time is t. So this will be v plus at dt, and this will be, suppose the displacement, the initial displacement be x0 and the upper final displacement be x. So this will be dx. Okay, are you getting the things? Yes. So this will what came out of while we integrate on both sides. So now solving this, since v0, this will become 1 0 t. Okay, and this will be half dt, to say the t square. Okay, t square 1 by 2. Okay, so this will take lower limit and upper limit. This is x0, this is what t, and on the similar hand side we will do 1 upon x0 upon x. Okay. Now put this, firstly what we will do, that put this t in this over here, can be minus 0. Similarly for this, just put t as a t, then t is equal to 0. This is what the difference between the final time taken and initial time taken. This will be the same, and this is what the difference between the original displacement upon the initial displacement. So this will be v t minus 0 plus half t square minus 0 का square. Okay, this will be x minus x0. Now solving it further, open this bracket on the left hand side. So we will get Vt is equals to half a t. Where is a? Actually we have forget this to write a over here. A is a constant, so in a previous step a will be can thought of as a common. Okay, so this is a, right? I forget to write a over here, so this will be x minus x0. Put the value, just transfer this value over here. So you will get x is equal to x0 plus v0t vt plus half at square. So this is what, nothing but your s only. The difference between x minus x or s, that is what vt plus half vt square. This is what, nothing but the second equation of motion. So we have solved the third. This is what equation number 2, the second equation of motion. Now we are going to see the proof of the third equation of motion. Okay, for this we know that acceleration is dv upon dt. Will you find any change if I write this as a dv upon dx and dx upon dt? So since this dx will cancel out, so it will be remain same as above. So there is no much difference between this and this. So now we know that the value of dx upon dt is nothing but what? This is what, nothing but velocity or no? This is since dx upon dt is nothing but velocity only. So put the value of dx upon dt over here. So you will get dv upon x into v. Okay, dx. Transfer this dx over here. So you will get dx and this will be v dv. I have just transferred this dx to the left hand side, and the right hand side I have written that it is same as it is in a previous state. Now integrating both sides, you will see that since acceleration is a constant, so this will come out as a common, and the lower limit is x0, upper limit is x. This is what x. Just similar to what we did on a previous step, we just do the same things. So this will be integrated as a v0, lower limit as a v0 and upper limit as a v, and put this dv. Okay, now solving this equation furthermore, you will get that since there is a no function, so function is equal to 1. So this is what, nothing but after solving it is 1 x0 upon x is equals to 1 v square on 2. This is what, v0 on v. Okay, so solving this furthermore, you will get a x minus x0 plus half v square minus u0 square. Okay. Transfer this 2 to the left hand side. You will get 2a x minus x0 is equals to v square minus u square. Solving it further, you will get v square is equals to u0 square plus 2a x minus x0. This is what we have finally come to the conclusion. We have finally come to the conclusion that this is what, nothing but your put either you can replace this x minus x0 is equal to s. Replace x minus x is equal to s. You will get that v square is equal to u square plus 2as. So this is what, nothing but the third equation of motion for the constant acceleration. The application of this theorem is that it is also applicable for the non-uniform acceleration motion. So yes, we have done the proof of all the three equations of motion. Thank you.